Okay, so when we talked about solving absolute value equations, we had something like this, and we said it equaled 2. And we defined absolute value as the distance a number is from 0 on the number line, correct? And so we have two solutions. Two numbers on the number line have an absolute value that is equal to 2, and that's 2 and negative 2. So on our number line, the solution to this would be 2 and negative 2. Or there we go. Stars are the answers. Okay, so yeah, I'm finding other things that I can use on this, so why not? Let's do it. So absolute value equation, we have either two answers, or yesterday I think you found out you could have one answer. If our absolute value equaled 0, we would just get one solution. Sometimes we get no solution. So absolute value equation, 3 possible answers. 2 answers, 1 answer, no answer. No solution. Absolute value inequalities. Let's talk about if we had something like this. If we had that the absolute value of something was less than 2. So what that means is the distance x is from 0 is less than 2 units away. So if that's the case, what numbers are less than 2 units away from 0 on our number line?
Well, everything. Less than negative 2 and everything. Well, greater than negative 2 and everything.
So this number right
Less
there
than 2.
has an absolute value that is less than 2 units away. This value here, all of these in here, all of the solution, or all the values in between negative 2 and 2 have an absolute value that is less than 2. The distance it is from 0 is less than 2 units. So then we could say that what if we're looking at absolute value and it is greater than 2? What if our absolute value is greater than 2? That means the distance our number is from 0 is greater than 2 units. So that would be, that would have to be from 2 out, correct? Because all of those numbers' absolute values are greater than 2, as well as negative 2 that direction. Because if you took a negative 3, for example, the absolute value of negative 3 is greater than 2. So today we're working with the inequalities, and I want you to keep this in mind on this one up here, this graph, on the middle graph. That's like an in-between, like the last one we did on our bell work. So we're talking about values in between two numbers. And then the last graph is just the union of two sets of numbers. So let's look at the generalization that we're going to use when we're solving inequalities, and then we'll go through a couple of examples. So when we have a problem that states the absolute value of x is greater than a, and as long as a is positive, then we will rewrite it or say that the solution is that x will be greater than a, or x is less than a negative a. And then when we have an absolute value of x that is less than a, again with a being positive, we are going to write it as the union, and so x will be in between positive a and negative a. So it's going to be greater than negative a and less than positive a, because the absolute value is less than a. So it's got to be everything in between those two values. Notice that with each one of these, the absolute value is isolated. So we can't have anything else with the absolute value, nothing multiplied in front, nothing added or subtracted outside of it. We have to have it isolated first before we can determine whether we're going to write, we're going to write this or that to help us solve. Okay, so before we can determine whether we're going to, how we're going to write our inequalities to solve for x, we have to isolate the absolute value. So the very first thing, like you would with an equal sign, we would add 10 to both sides. And that's going to give me the absolute value of x plus 4 is less than or equal to 8. Okay, so that is like the second one here, correct? If it's less than a value, that means it's going to be in between two sets of numbers. So in this case, 8 is positive, so it's all good. X plus 4, the absolute value of x plus 4 is less than or equal to 8. So that means that x plus 4 is going to be in between 8 and a negative 8. And we can leave it in this form now. And similar to number 3 on today's bell work, we want to isolate x in the middle. So whatever we do to the middle, we do to the two outsides. So to get x by itself in the middle, we're going to subtract 4. So I subtract 4 here, means I'm going to subtract 4 from the two outside values. And I'm going to get a negative 12. I have x by itself in the middle, and I have 4 on the right. So I could read this as x is in between a negative 12 and 4, inclusive. And the inclusive means the equal sign. So how would we graph that? Well, we've got a number line. We've got negative 12. We've got 0, and then we got 4. So they are both equal to, so we would have a filled-in circle at each of those values. And because x is in between, so x is less than or equal to 4 and greater than or equal to negative 12. So it's those numbers in between. And this would be our solution in terms of an inequality. This would be our solution in terms of a graph. And just for fun, what would we write it as in terms of a interval notation? How would we write this? Bracket.
Negative 12 for bracket.
There we go. So that we may write our solution that way as well. And before we can rewrite our inequality as two inequalities or a compound with and inequality, we've got to isolate the absolute value. So first step here, divide by 3. Both sides. And we're dividing by a positive, so that doesn't change anything on our inequality. We leave it as it is. So we have x minus 7 is greater than or equal to 3. And if you remember from the earlier page when we had the absolute value of x is greater than a, then we would say x is greater than a, or x is less than negative a. So this is a greater than, it also is equal to, so we're going to write two inequalities. We're going to say x minus 7 is greater than a, or not a, 3. Or x minus 7 will be less than or equal to got to put equal to -3. I need to go back and make sure I said that correctly on the other stuff. So get this written down, and I'm going to go back and make sure I have that. I'm going to add 7 here to get x is greater than or equal to 10, or I'm going to add 7 on both sides there. That will give me x is less than or equal to 4. And in graphing greater than or equal to 10, what's that going to be, Cameron? How do I graph greater than or equal to 10? So greater than 10, which direction, right or left? Arrow to the right, very good. And then less than or equal to 4, Ethan? Okay, so 2 solutions that we have. This is the inequality we would write. This is the graph. How would we write this in interval notation now? How would we write those two? Basically, it's 2 separate graphs. How would we write those?
2 different interval notations.
2 interval notations. So okay, Anna, how would you write x is less than or equal to 4, interval notation? Okay, and then we want to show that it's both. So we would use this U, means the union put together. So we would want to put union, and then what's the second one? Hold on, I've got to do something here so I can put those together. So the first one again was -infinity to 4 with a bracket. And we also want to include, so we have to use that U to include the second half of it. So, Gavin, how would I say greater than or equal to 10?
Bracket 10 plus a positive infinity.
Yep, there we go. So there's our third way we could state our answer to this absolute value inequality. Okay. Let's do one more. Okay, Zami, walk me through first step. What am I going to do?
Subtract 15 from 15 and 21.
So I get absolute value of 4 minus x is greater than 6. Okay, Ellie Weber, what do I do now? Next step. Okay, so this is greater than. So greater than means we're going to write it as 2 separate ones. So the first one is going to be, not that. 4 minus x is greater than 6, or 4 minus x is less than -6. Okay, so when it's greater than, we're going to write 2 separate inequalities connected with or. When it's less than, that's when we'll put it in between. Okay, so Aiden Ball, what do I do now? So we wrote 2 inequalities connected by or because it was greater than. And we had to change the direction of the inequalities. So now we're going to graph less than -2 would be open circle at -2 to the left. Greater than 10 would be, and I've talked too